example on general motion. So yesterday, unfortunately, I took out my shoe to convince you what? To convince you that friction force is acting in this direction. And why is it in this direction? Because the applied force is all, the friction force is always relative to the what? To the applied force. Are we clear? Okay, so in this context, the friction force goes opposite to the applied force. Okay, so now we come into the kinetics of the analysis. So on the kinetics of the analysis, we know that over here we have a m AGX, okay, and we also do have a rotation that is I naught alpha, okay, which is also I naught alpha. So given the information that we are given, let's read the question again. Okay, so the circular concrete curved row with an angular velocity of 0.5 radians per second. So omega is equal to 0.5 radians per second. Okay. When the man is at the position shown, at this instant, the center of gravity of the culvert and the man is located at point G, and the radius of gyration about point G is 3.5 feet. Okay, so this makes our life easy because we don't have enough information to calculate the mass moment of inertia. So given this information over here has been really helpful. Determine the angular acceleration of the culvert. The combined weight of the culvert and the man is 500 pounds. Assume that the culvert rolls without slipping and the man does not move within the culvert. Okay. So without slipping, as we mentioned yesterday, we cannot use what? Friction force equal mu n. But it does not mean there is no what? Friction. Are we clear? There is still friction, but we cannot use what? Ff is equal to what? Mu n. Okay. And A, so however, we can use acceleration is equal to alpha r. So that is the good news. Okay. So from here, we can calculate, did we calculate our mass moment of inertia? So immediately calculate what we know. Okay. So our mass moment of inertia is equal to mk squared. So the mass is equal to 500 divided by 32.2. And then given is 3.5 squared. By the way, I will post the formula sheet for your exam, okay? Now, the formula sheet is very general. Do not try to look at the formula sheet and guess what question is going to come out. It's going to waste your time. Are we clear? Okay. So this is equal to 190.22 slug feet squared. Okay. So the next obvious thing to do is we're going to do summation forces in the x direction. So summation of forces in the x direction and y direction is really, really straightforward. I think you guys see me doing this so many times and say, Eugene, yeah, we know. Okay. So we know that this will be equal to what? FF, friction force, is equal to friction force is equal to M. So the mass. So AGX is going towards the right hand side. So this will be your AGX. And then with this, it's going to 115.528. And then this is your AGX. And this is your equation number 1. Okay. Then we have summation about forces in the y direction, M A G Y. So in the y, you will have N minus by 500. Anything else? You got nothing else. So this will be equal to M AGY. Okay. I do apologize. There is a AGY coming here. Okay. So from here, again, so we know that this will be equal to 15.528 bracket, and we have our AGY. Equation number 2. Then from here, we're going to take our moment from point O. Okay, so I will copy the whole thing. And I know some of you are still writing. I'll leave you to write for a bit. Okay, so I will have the diagram. Oh, by the way, in your term test or in your exam, it's slightly different, as in you'll be writing on a piece of or on a booklet, and the questions are on a different piece of paper. Okay, so it'll be easier for you. Don't get the numbers wrong, you cheeky sort. Get the numbers wrong, I will like, okay. So I'm going to do summation about moment. I just decided to put at point O, and then we also have summation about moment at point O, kinetic. Okay. So we are going to take moment at point O. So this is where we have point O, right? So the first thing we realize that the FF is going to generate a moment and it's going to anti-clockwise. So we know that the radius is 4 feet over here. So you have 4 FF, right? And then the next one, the 500 is going to do a clockwise. Okay, the 500 over here. So minus 0.5 multiplied by 500. Anything else generating a moment? So we don't need to consider N because we are taking from point O. Okay. Then the whole thing will be equal to, so I naught alpha, so it's minus 190.22 alpha. So remember, this is calculated, right? This is our what? I naught, right? And then minus, right? So we are taking from point O. When we are taking from point O, MAGX does not have a moment at all because there is no perpendicular distance. But MAGY does have a what? Does have a moment. Okay, so so it's 15.528. Okay, AGY. And then multiply by a distance of 0.5. Okay. Now, some of you might wonder about this. Okay. Why? All right. Let me put it more clear. Why is there MGY at point G? Should there be one? Right. At O, there will not be any what? MAGY at all, or MA not Y. Are we clear? Because at point O is directly at this point, yes or no? There is no what? Vertical movement. Well, when you do an offset over here at point G, right? Could you imagine when you're going around, you do come down also? Okay, your steps is not just one direction, right? It's circular. So in a circular motion, you have the forward motion and you also have downward motion. Are we clear? So that's why you have a MAGY. I think this is the only part that make this question a bit what do you call tricky. Okay. Right. So from here you have nothing else. So you just need to calculate. So 4FF minus by 500 minus by 250 is equal to minus 190.22 alpha. And then over here, you will have 15.528 times by 0.5, 7.764 AGY. Okay. So this is our equation number 3. So at this stage, we check stocks. Okay. So we have 3 equations. And our unknown is alpha, FF. So let me put unknowns. Our FF, we have alpha, we have AGY. Okay, now we have 3 equations. If it's 3 unknown, hallelujah. But no, we also don't know what is our what? What is our N? Right? Unfortunately, for N, we cannot use what? Right? We cannot use this expression over here. Right? So we need to form another equation. And you guys have seen this before. What we are going to form is we are now going into what? Okay, so whenever you have the trend where you have 3 equations and 4 unknowns, right? To get another expression, we have to go into what? Kinematics what? Analysis. It's like your structure is statically indeterminate. Some mention about forces in the X, Y, and moment about Z. Cannot solve your equation. What must you do? You use deflection is equal to what? PL over what? AE. Yes or no? Is your 2 P04 cumulative or no? Yes or no? Or you don't know? Holy crap. Okay. So, any idea? Anyone? Oh, you'll be fine. You want me to find out for you? Okay, I'm going to ask him. Right. So from here, we need a kinematics analysis. So now I decide to we decide to pick point G and point O. Okay. Now, why I pick point G and point O for kinetic analysis? Because at point O, right, at point O, so we're going to pick kinematic analysis about point G and point O. And this is because at point O, right, there is only what? M A not X. We don't have what? We don't have Y. Okay. So now we start writing an expression, and you guys are really good in this now. So we're going to see AG is equal to A naught plus by alpha cross R G from point O minus by omega squared R G from point O. Now for this case, you have to be very, very careful because it's omega equal to 0. we realize that omega is not equal to 0. But is there a value given? The answer is yes. The value of omega that we are given is what? 0.5 radians per second. Okay, as it is over here. Okay, so from here